Hey everyone, today we're going to go over the last bit of content for this chapter. We're going to be talking about areas of segments, and this is going to be very closely related to what we did in the last video, which was the area of sectors. So if you're still having trouble with that, it'll be really important to get that down, so that area of segments then should become pretty easy. So a segment, this is something we haven't talked about before. And so what it is, a segment of a circle is a region bounded by an arc and its chord. And that word chord is a new word, so let's take a look at what that means. So remember, arc, we said, was the piece of a circle that's in between two endpoints. So here we're talking about R and Q, and the arc is that piece along the circle that's in between those two endpoints. So that's the arc. The arc was the part of the circle, and so I'm going to make that note again here. Okay, now the chord, if I were to take those two same endpoints and connect them, that's the chord. So that's what we're talking about with the chord there, just connecting those points that are on the circle. And so the segment then is everything that's in between those two things. Okay, so in our picture, that shaded region is a segment. So those are the things that we're going to be finding the area of today. So the area formula, this one's a little different. We're going to kind of lay it out more in words than an actual formula. And here's how it works. So here we have in this picture, this is the area of the segment. And again, the segment is this little piece here. So this is what we're trying to find. Okay, that's our segment. That blue I know does not show up well, but it's the shaded part. So to get the area of the segment, what we're going to do first, that's going to be equal to the area of the sector. Remember, which was like our piece of pie that we took out of the circle. And we're going to subtract the area of a triangle. And I'll show you that in a second here. So that shaded piece is our sector, and what we're going to do is take out this triangle that's bounded by the radii and the chord. And so that orange piece, again, hardly shows up, but this piece, if we take away this triangle out of the sector, then we're going to just be left with the segment. Now, for the triangle, we could be using one of two formulas. If we know that central angle is a right angle, so in other words, we have a right triangle, we might be using area equals 1/2 base times height. If we don't have a central angle that's 90 degrees, remember we have our 1/2 AB sine C. So we're going to be using one of those two formulas depending on what our example or our problem looks like. So let's go ahead and look at number 5. So here we've got our segment, we can see here. And so now we're finding the area, and we're just going to round these. We don't need to leave them exact. So we said to find the area of the segment, what we're first going to do is find the area of the whole sector. So the sector I know is going to be everything that I'm outlining here. So to find that area, we know it's the area of the circle, pi r squared, times the fractional piece of that circle. And remember that m is really the measure of the central angle. So in our case, we have pi, my radius is 10. Now here we have a right angle, so our m is 90. And we put that over 360. So for right now at this intermediate step, I'm going to leave my answer exact. So I'm just going to do 10 squared, and I'm going to do times 90 over 360. So the area of my sector is 25, and I'm going to multiply that pi. So I get an area of 25 pi for my the sector. Now to get the area of the segment, I need to subtract the area of this triangle. And what I notice here is since I have a right angle, I can use my 1/2 base times height. In this case, the base and height are both just the radius of that circle. So I have times 10 times 10. 10 times 10 is 100, divided by 2 is 50. So now I'm going to take the area of the sector minus the area of the triangle, and that'll give me the area of the segment. So my area is going to be 25 pi minus 50. Notice I've left it exact up until this point, and now I can put it in my calculator. So 25 pi minus 50, and I get 28 point, let's see, it was hundredths, so that's 2 places, so 28.54. And of course, we still want to include our units, so we have inches squared. Okay, so that's going to be the basic idea here. We're just going to do a few more examples that look a little different. Actually, the next one is a right triangle as well. So again, this might be a good one if you feel like you've already got the feel of this, to pause and try it on your own. Otherwise, I'll go through it here in the video as well. So again, we're trying to find the area of the shaded segment here. So we know we're going to start off with the area of the sector. Again, the area of the sector is the radius of the area of the whole circle, and then we're just taking that fractional part, times m over 360. So now my radius is 4. Again, I still have a right angle, so my m is 90. And we're just going to put that in our calculator. So I have, let's see, 4 squared times 90 over 360. And that's just going to give me 4 pi. So now that was, sorry, let me go back. That was my whole pi shape here. Now to get the shaded part that's left over, I need to subtract out this triangle. Again, I have a right angle here, so it's going to allow me to use area equals 1/2 base times height. And again, the base and the height are both the radii, so they're just both 4. So 4 times 4 is 16, divided by 2 is 8. So now to get the area of that segment, I'm just going to take my 4 pi minus 8, and now use the calculator to get my rounded answer. So to the hundredth, again, that's 2 places. So this is going to be 4.57. And my units are meters squared. Okay, so in both of those, we were using our area equals 1/2 base times height. And again, we were able to do that because this central angle here had a measure of 90 degrees. So the next two we look at are going to be a little bit different. So in number 7, there's actually a few things going on here. So I can see the segment is the shaded region here. So I know that corresponds to this sector. Right? This is the sector that includes that segment. Now I have to be careful here. They've given me 60, but that's not the angle that I need for my sector. So since this is a semicircle here, I know there's 180 degrees. So if I subtract 60, I get 120. And that's going to give me the angle measure that I need to use in my problem. So again, we start with the sector, which is pi r squared times m over 360. Now, we have to also be careful here. They're giving us the diameter of that circle. So to get the radius, we know we have to divide that in half. So my radius is 4. And then my central angle is 120 degrees. So again, go to my calculator. I'm leaving pi out for now. Oops. 120 over 360. And I get 16 over 3. Put this here. So my answer is going to be times pi is 16 pi over 3. Again, we're leaving it exact at this point. Now, our second step is still the same. We have to subtract out the triangle here. But you'll notice that triangle is not a right triangle anymore. That angle is 120 degrees. So we can't use half base times height. Here we're going to have to use half AB times the sine of C. So now our A and our B, the sides of that triangle, are both going to be the radii of our circle, which we know is 4. And then I'm going to take the sine of that angle, which is 120. So actually what I'm going to do at this point is leave the sine 120. I'm just going to work with my constants here. So 4 times 4 is 16, divided by 2 is 8. So I'm going to leave that as 8 times the sine of 120. Remember, we don't want you rounding at these middle steps. We want to leave it exact until the very last step. So now I've got the sector and my triangle. To get my segment here, I'm just going to subtract those two. So I'm going to do areas equal to 16 pi over 3 minus 8 times the sine of 120. And now I'll go to my calculator and put this all in. So 16 pi over 3 minus 8 times the sine of 120. And let's see, we're going to the hundredths, so 9.83. And I don't have units, so I'm just going to do U squared for my generic units. All right, one more to go. Again, this is actually more straightforward than the last one. So if you got the last one, again, this might be a good time to just pause the video and try it out on your own to see how you're doing with this. Again, same 3 steps. The first thing I do is I find the area of my sector, my pi piece here. Pi r squared, times m over 360. And this, everything is given to us very directly, so we don't have to change anything. So my radius is 5, and my angle is 60. So going to my calculator, I'm going to do 5 squared times 60 over 360. And so I get 25 pi over 6. And the calculator gives me 25 over 6, but then I know I need to bring my pi with, so I have 25 pi over 6. Next step is to take out my triangle. And again, I obviously do not have a right triangle here, since that angle is 60. So we're going to use our A equals 1/2 AB sine C. Again, A and B, the sides of my triangle are just the radii of the circle, so they're both 5 times the sine of my angle, which is 60. Again, I'm going to leave the sine 60 in for right now. So I'm just going to do 5 times 5 is 25, divided by 2 is 12.5 times the sine of 60. And I leave it there until my last step, which is next. Finding the segment, I take the sector minus the area of the triangle. And then once I've got this, then I can round everything. So let's see here. Put this where it doesn't have a glare, hopefully. I have 25 pi over 6 minus 12.5 sine of 60. And it looks like I get 2.26 square units. All right, so that is the last video for this chapter. From here on out, we'll do some practice, then your review and test.